In this video, I'd like to talk about the math question of the day for February 17th, 2023. And with this problem, we need to find the zeros of the polynomial function f of x, which is shown here. And to answer a question like this, you need to have a solid understanding of Algebra 1 and Algebra 2. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, we can go through this together. Now, assuming that you have attempted the problem, we can start working through it together. And if you do have suggestions for future questions of the day, feel free to leave those as a comment. Now, when a question asks to find the zeros of some function, it's just asking which x values would make this function equal to 0. And if we can somehow rewrite this function in a factored form, this question is fairly simple to answer. Since, let's say, as an example, we have g of x is equal to x minus 3, x plus 4 multiplied by x minus 1. And if we want to know the zeros of this function, we can use what's called the zero product property. If one of these factors is 0, then you have 0 multiplied by something, but 0 times anything is always 0. So for instance, if x is 3, then this becomes 0, and 0 multiplied by 7 multiplied by 2 would still be 0. And likewise, the other solutions would be -4 and +1 for similar reasons. And again, that property is called the zero product property. So we want to apply that here, but to do that, we need to factor this polynomial. And factoring polynomials when the degree is bigger than 2 can be a little bit challenging. There just aren't that many methods to do it. But this one, it looks like we can factor using the grouping method. And that's a method you should always check if you have 4 different terms, since you need to pair 2 of them together and then pair the other 2 together, and then you pull out the greatest common factor. And we can start by just rewriting. Now, I should mention factoring by grouping usually doesn't work. If I tweaked any of these numbers by just a little bit, then that method will fail. For instance, if this is a 15, a 14, a 13, then it doesn't work. But if the numbers are perfectly crafted, then sometimes it does work, and it can be a very useful method. So our function is a cubic function, a cubic polynomial to the 3rd degree. We have x cubed plus 4x squared minus 4x minus 16. And with grouping, you are free to choose what to group. Though in this case, I will just group the first 2 and the second 2. But if you want to mix up the order, maybe group the 4's together or the last 2 together, you can try that as well, but it doesn't always work. So you need to be careful with your grouping choices. And once we choose what to group, we're just going to pull out the greatest common factor. We're looking for the biggest number or term that would divide evenly into both of these. And it looks like they each share 2 x's. This one has 3 multiplied together, and this one has 2. But if we pulled out an x squared, then we'd have 1 left here, and this would just have a 4 left. And of course, you can check this by just redistributing. Now, for this next term, we can pull out a negative, since both of these are negative, and it looks like we can factor out a 4. And when we factor out -4, we are just dividing each of these by -4. This would just be positive x, and this would be positive 4. Now, the key point here is to notice that we ended up with the exact same expression in both of these parentheses. And if that wasn't the case, then grouping won't work. So that's a way to check that you're on the right path or that grouping is even possible, is that you will end up with this same expression once you pair them up, pair this one and this one, pull out the greatest common factor from each, and if what you're left with is the same expression, then you know you're on the right track. Now from here, we can further factor this by factoring out this x plus 4, since each of these terms has x plus 4 in common. So when we factor that out from each of these, for this term on the left, we are left with an x squared, and for the term on the right, we're left with a -4. And at this point, we can see if we can factor any further, and it looks like we can, because this is a difference of 2 squares. And in general, remember that if we have a squared minus b squared, this can be factored as a minus b multiplied by a plus b. It's the first one minus the second one, ignoring the squares, multiplied by the first one plus the second one. So if we can identify what's squared here, we can apply this formula. We'll just rewrite the x plus 4, and it looks like we have, of course, x squared, and 4 is really just 2 squared. So x squared minus 2 squared, meaning if we match it up to the formula, a is x and b is 2. And let's just rewrite everything. We have that f of x is this x plus 4 multiplied by this difference of squares. We'll now apply the formula. We have the first one minus the second one, ignoring the squares, and the first one plus the second one, again ignoring the squares. And now that we have this in its factored form, we can set it equal to 0. And to solve this, we use that zero product property. Notice that when x is negative 4, this becomes 0, and 0 multiplied by negative 6 multiplied by negative 2 is still 0. So negative 4 is a solution. If we plug in 2 here, that will make this 0, and if we plug in negative 2 here, that will make this 0. So it looks like the zeros of this polynomial function are negative 4, 2, and negative 2. And one way to check that you're doing this correctly is to just go back to your original function and test it. If you plug in, let's say 2, do you get back 0? And we can do this very quickly. We would have 2 cubed, which is 8, plus 4 times by 4, that's 16. 8 plus 16 is 24. Minus 4 times 2, which is 8. 24 minus 8 is 16. And then 16 minus 16 is 0. So it does make sense when you plug this back in that the function is equal to 0. And I encourage you check the other two values as well, just to make sure that you're doing this correctly.